that down. Radical expressions. We're going to simplify radical expressions. What is a radical? Besides something that's rad. Okay, what's a radical? You heard square root before? Okay, it's a square root. Okay, so what does square root mean for radical? What number times itself gives you what's underneath the radical, right? So we have a list of perfect squares that we can write down. Okay, what numbers are perfect squares? Is 1 a perfect square? What's square root of 1? 1. So it would be a perfect square. We're going to skip 1. We're going to go to the next one. What's the next number that has a number times itself? Yeah, 4. 2 doesn't. Is there a number times itself that gives you 2? No. How about 9?
Yeah.
Is 3 times 3 9? What's the next one? 16. Next one?
6 times 6.
36. 64. Not 72. 81. 100. What's the next one? 121, which would be for 11.
141.
44. 169, 196, 225. That's probably enough. Okay, so here's a list of perfect squares. You're going to want that list of perfect squares because we're going to have to break up certain radicals today. Okay, so if you look at the square root of 12, is that on our list of perfect squares? No. Is there a number times itself that gives you 12? No. So what we've got to do is we've got to find one of these perfect squares that divides into 12. Okay, so you guys can use calculators today. If you've got calculators, you might want to get those out. So going down my list, I'm going to start with 4, and I'm going to try to divide 4 into 12. Does 4 go into 12?
Yes.
Yeah, so we're going to break that up as 4 times 3. Everybody agrees that 4 times 3 is 12, right?
Yep.
Okay, now, we can take the square root of 4 because we know the square root of 4 is what? 2 times 2, which would come out as 2. So we're going to take 4 out as 2. We're going to leave the 3. So now we have 2 radical 3.
This is what we're doing?
Yes. So if there's more than one of these perfect squares that goes into the number that we're trying to break up, always pick the biggest perfect square that goes in. Okay? That way you don't have to break it up twice. And we'll get to ones like that. Okay, write those two down. Try to work them out. For 75, we're going to go all the way down here and we'll get to 25 and we'll see that 25 goes in. 48, there's a couple different ways you can work that one out. So break up underneath your square root first, then bring out your perfect squares. And again, use your calculator. Divide these perfect squares into the number that you see. So like Cooper said on this first one, 25 times 3. And when I break up my perfect squares, I always put the perfect square before the non-perfect square. Okay, because I know 25 is going to come out as what? What's square root of 25? 5. So cross that off, bring the 5 out of the radical, leave the 3. So 5, radical 3. Has anybody started on 48? What goes into 48? 16. Okay, always go with the biggest perfect square. If you didn't see that 16 went in there and you used 4, always check to see if 16, maybe 36, maybe even 64 or 100. Okay, those would be, if 4 goes into it, those other numbers may go into it. Okay, if 9 goes into something, what else might go into it?
49.
Could 36 maybe? And 81 maybe? So if 9 goes in, maybe check those ones to see if they go in. Okay, so looking at 48, let's say we forgot and we went 4 times 12. Well, what's the square root of 4? 2. So 2 radical 12. But does 12 break up?
Yes.
Yeah, we just broke up 12, right? So this is 2 radical 4 times 3. The 4 could come out as what? 2. Whatever comes out, if there's a number in front, you're going to multiply by that. So the 2 comes out, multiplies by the 2 to give you 4 radical 3. Okay, let's go this way though. If we go 16 times 3, what's the square root of 16? 4. Do we get to 4 radical 3 a lot quicker?
Yeah.
Okay, so always try to break it up with the biggest perfect square. All right? Write those two down. Okay, looking at this first one, 125 is not a perfect square itself. Is 144? Is it on our list of perfect squares?
Yes.
Do we need to break it up if it's already a perfect square? No. 125 we're going to have to break up though. What perfect square goes into 125? 25. So we're going to go 25 times 5. So there's 5 quarters in the $1.25, right? Right, Diaz? Okay. 144 we're not going to break up. We're going to leave it as 144. Then we're going to take out our perfect squares. 25 is going to come out as 5. This is going to stay underneath the radical, and it can be its separate radical. So we're going to go 5 radical 5 over. This comes out as 12. Okay. Go ahead and try that second one up there. Try to figure out what goes into 243. 100, do you need to break up 100? No. No, because it's already a perfect square. Class this algebra. When I integrate, it's 5th. Some kind of power drink in the morning here? Oh, energy. It's that time of year. Anybody find what goes into 243?
Yeah, 81.
Okay. Did 9 go in there? Yeah, 9 went in there, so what are you going to check if 9 goes to try to find a bigger one? Either 36 or 81. 81 goes in there 3 times, right? So we're going to break that up. 81 times 3. The 100 is going to stay just 100. Do not break it up as 10 times 10. Okay, I see students do that all the time. Just know that the square root of 100 is going to come out as 10. So this comes out as 9. The 3's staying underneath the radical. That's coming out as 10. Who had that before I got there? Does everybody understand? Yeah? Try those two. That's a 539. I guess I had sloppier handwriting about 7, 8 years ago.
That's how old these are? You keep them?
I keep them. I manipulate them from time to time, but same lesson plans. $539. Anybody?
430 or 49.
49 times
11.
11. Okay, 100. You don't need to break up. How about over here? Did anybody break these up yet? Keep working on that. I saved this radical stuff because then we just leads into the imaginary number stuff that I'm going to do.
Your imaginary number.
I just get through everything, so yeah, I do that at the end. Whether they remember it or not. Probably not. Okay, 128, what goes in there?
64.
64 times, and 147.
That's perfect.
It's not a perfect square, but is there a perfect square that goes into it?
Yeah.
49 times
2.
3. Okay, so those are broke up. This is broke up. Over here on the left, you're going to get 7 radical 11 over 10. Over here, square root of 64,
8.
8. So that's coming out as 8. The 2 is going to stay. Over 49 comes out as 7. The 3 is going to stay. Anybody get that one? That was a little tougher. Okay, there wasn't a perfect square in here. We had to break up both numbers. Okay, next one. Okay, is 27 one of our perfect squares?
No.
No, but what goes into 27? 9. Now we're going to start getting some variables with exponents, and we're going to take the square root of those. So let's just come over here. What's the square root of an x squared? Okay, how do we know that? Because x times x equals x squared. Okay, so what times itself gives you that? So that comes out as x. What they're going to do if you bring out a single x or a single variable is they're going to put an absolute value around that. Okay, on the test, I'm not too concerned whether you put that absolute value around it. They put the absolute value because 2 squared could equal 4 or negative 2 squared could equal 4. Well, you can't have a negative underneath a square root or it's an imaginary number. So that's why they put the absolute value. Okay. What's the square root of x to the 6th? X to the 3rd. So essentially, what are you doing to the exponent when you take a square root? You're dividing by 2. So keep that in mind. Okay, so breaking this up now, 9 times 3, and keep the x squared as x squared because it's going to come out evenly. Okay, break everything up, then bring out your even squares. 9 is going to come out as 3, 3 is going to stay, x squared is going to come out as x. They will put the absolute value around that, radical 3. Again, on the test, I'm not too concerned. If you just have 3x radical 3, that's fine. Try that one. Need to break up 96. Did everybody write their list of perfect squares in their notes? Okay, you're going to want that for the test. Did 4 go into 96? So what else might go in there? 16. So 16 times 6, x to the 4th. This comes out as 4, 6 is going to stay. X to the 4th comes out as x squared. They won't put an absolute value around that. They'll leave it just like that. Everybody getting it? And now it gets a little trickier. Write that down. So when you take a square root, you divide by 2 to the exponent, right? If I've got a 9, does 9 divide by 2 evenly? No. So anytime you get a negative or an odd exponent, we've got to break that variable term up. So first off, we're going to break up 8. What goes into 8 that's a perfect square? 4 times 2. Okay, don't bring out a 4 and leave a 2. Break it up inside here is 4 times 2. X to the 9th, you're going to drop down 1 and times by itself. Because x to the 8th times x is the same as x to the 9th. Right? Because 8 plus 1 would give you the 9. So anytime you have an odd exponent, okay, drop it down 1 times it by itself. And then y squared is going to stay the same. 4 is going to come out now as 2. 2 is going to stay. What does x to the 8th come out as? X to the what? 4th. We can't bring that x to the 1st out. We're leaving 1 inside. And then that y squared is going to come out as y. They may put the absolute value around that y. Square root of what's left? 2x. Everybody understand the odd exponents? Drop it down 1 times it by itself. So if I had the square root of x to the 11th, how would I break that up? So it would be what? X to the, drop it down 1/10 times x. What's x to the 10th come out as? X to the 5th, what's going to stay? The 1x. Now, oh, and we got x to the 11th there. It's easiest just to use a calculator with these, dividing in with by your perfect squares. 75, how are you going to break that up? 25 times 3, x to the 11th, like we said, x to the 10th times x. Y to the 4th is going to stay as y to the 4th. We've broke up everything that we need to break up. Now we're going to bring out perfect squares. 25 comes out as 5, 3 stays, x to the 5th, x stays, y to the 2nd, radical 3x. Everybody getting it? Stanley? Kind of? Till you get your paper and then you're like, oh, crap. Oh, nice work. Okay, here's a couple other tricky ones. Okay, do we need to break up anything here? Is 49 and 121 on our list?
Yeah.
They're both on the list. So if we take the square root of 49, it's 7, and this would come out as 11. Do I still have radicals over that if I brought them out evenly? No. And you'll probably see answers where they still have radicals over the top. Yeah, it's just 7/11ths. Okay? Don't put square roots over the top. Yeah, it's not 7/11 where you get Slurpees. It's 7/11ths. Okay? This one. Do we need to break anything up?
No.
No, that's an even exponent. Only odd exponent ones that we got to break up. So this comes out as 6. That comes out as x. What will they do with the x, though? Absolute value. Everybody good?